You'll notice here that we have three different triangles. All have 45-degree angles, and with the lengths of the legs inserted, and each of the hypotenuse measurements missing. I'd like you to take a few minutes and solve each of these using Pythagoras' theorem. Now, keep in mind that the hypotenuse must always be our C value, and that our hypotenuse is always across from the right angle. But when you solve these, I don't want you to use a calculator. I want you to simplify these so that your answer is in simplest radical form. Okay, so remember to simplify the square roots. We did that right before, we did those last week. So I want don't put your answers in decimal form. Leave your answer in simplest radical form. Take a few minutes, pause the video, and see if you can do that for these three triangles. So if we take a look at the first one, I'm going to do 3 squared plus 3 squared equals x squared. So that gives me 9 plus 9 equals x squared, or x squared is equal to 18. Now remember, the inverse of squaring a number is to take the square root. So my hypotenuse is equal to the square root of 18. Now remember, when we're simplifying these, I want to factor out as many perfect squares as I can. So I know that 9 times 2 equals 18. And I know that the square root of 9, and I can separate this into the square root of 9 times the square root of 2. Square root of 9 is 3, and of course, square root of 2 is in its simplest form, so that is the length of my hypotenuse. Now, I can do the same exact thing for 8. 8 squared plus 8 squared equals x squared. So I get 64 plus 64 equals x squared. When I add 64 plus 64, I get 128. So the length of the hypotenuse is the square root of 128. Now, I know that I can do 64 times 2 to get 128. So what I have is the square root of 64 times the square root of 2. And of course, the square root of 64 is 8. And if you did our third example, we're going to get is 100 plus 100 equals x squared or c squared. Of course, x is equal to the square root of 200. And then, of course, I can break that down as the square root of 100 times the square root of 2. So the length of my hypotenuse is 10 square root 2. You should see a pattern here. Okay, and the reason for this pattern is because the angle measures, in this particular case being 45, 45, 90, have a specific relationship with the side lengths. Now, because we know this, there is a shortcut that we can use for solving any 45, 45, 90 degree triangle. And this is what you'll see on your MCAS reference sheet is a model that looks like this. Okay, so what this tells me is that in any 45, 45 degree triangle, the legs of the triangle will have the same length. That's how we get the 45 degree angles. And the length of the hypotenuse will always be the length of the leg times the square root of 2. Okay, and this works for every 45, 45, 90 triangle. So for example, what you would see on your MCAST exam is something like this, and you would be asked what the length of the legs are. Now, based on the information we've just determined, that the number in front of the square root of 2 is actually the length of my leg. So each of my side lengths, each of my legs have a length of 4. So these are the easiest of the triangles to do. So let's say this was 7, and you know this is a 45, 45, 90. The length of my other leg obviously is going to be 7, and the length of my hypotenuse is going to be 7 times the square root of 2. So what we're trying to introduce here is the fact that when you have two 45-degree angles of a right triangle, the length of the legs will always be the same. If they weren't the same length, you wouldn't have a 45 to 45-degree angle. So this is unique specifically to 45, 45, 90 triangles. So keeping this in mind, that the legs are always the same length, and the hypotenuse is the length of the leg times the square root of 2, we can use this as opposed to using Pythagoras' theorem to solve for any missing side length. Now, one other thing I want to show you is just a reminder on what happens if one of my side lengths has a square root in it. So let's say my length of my leg is 3 square root 2. Okay, so that means obviously y is going to be 3 square root 2 because the legs are the same. Now, it's the entire length of the leg, which is 3 square root 2, times the square root of 2 that gives me the length of the hypotenuse. Okay, so when we are multiplying whole numbers and radicals, we can always, it's kind of like you want to think of it as multiplying variables and whole numbers. You multiply the numbers together and you multiply the variables together, but you can't intermix them. So what we're going to have is I can multiply the square root of 2 times the square root of 2, which gives me the square root of 4, which of course is 2. So that gives me a length of 6 for my hypotenuse. Okay, I'll do another example of that one. Okay, so let's say this is 5 square root 3. So obviously my leg is going to be 5 square root 3. And then based on my shortcut, it's the length of my leg, which is 5 square root 3 times the square root of 2. That will give me the length of the hypotenuse. So in this case, 3 and 2 are both prime numbers. So you just multiply that together, you get 5 square root 6, and that would be the length of my hypotenuse. So for these, that's really all you need to know for now. I mean, there is some more complicated problems that you might run into, but we'll save that for another day. Okay, Just keep in mind this shortcut right here. This tells me, and we proved it using Pythagoras' theorem, that anytime I have a 45, 45, 90 triangle, the lengths of my legs will be the same, exactly the same, and that the length of my hypotenuse will be the length of the leg times the square root of 2.